Okay, welcome to Module 12 of the Network Security Fundamentals series, where we will be discussing the authentication. By the end of this module, you will be able to describe the different types of authentication credentials, explain the different attacks on authentication, and describe how to implement authentication security solutions. So there are different type of authentications. Generally, in the past, we used to say something you are, something you have, something you know. We have expanded those categories to something you are, something you exhibit, something you can do, and something you actually know. Some of the examples are a password that you know what it is, a fingerprint scan, which is what you are, right? And something that you can exhibit, like your genetically determined characteristics that can be exhibited, right? Um, all in all together, the whole idea is to be able to authenticate the identification that you provide, whichever manner that is being provided, right? The other way of authentication is something that you can do, like performing an activity that cannot be exactly copied, like your dance signature, your dance move, and anything like that, right? So, all in all, together, identification is being provided, and authentication based on the identification is going to happen. We're going to start with talking about something that you know. Generally speaking, something you know is a password or a passphrase, right? These are the most common type of IT authentication from the beginning of the time till now. And of course, they have the pros and cons associated with them, right? Passwords provide only weak protection and are constantly under the attack. So attackers, bad actors are looking into the possibilities and the means to compromise the passwords, exploit and get those um, beautiful passwords of yours figured out, and then gain access to the resources that you're protecting with those passwords. Some of the weaknesses are, first of all, those are linked to human memory, and we cannot memorize long length of passwords. Later, we're going to discuss in order to make a password secure, one of the best ways is to uh, choose a password of a larger length, and that means the human being is gonna have difficulty remembering that, which is going to bring them to the fact that they're going to write it down somewhere, which by default is a vulnerability itself, right? You can still see some people who write down the passwords behind their keyboards, or on a piece of note in their wallet, or in a memory note in their phone or anything. So these are when they cannot memorize the passwords, right? So that's what the weakness of a password is. Um, Users must remember passwords for many different accounts, and that again causes problem because um, ideally these users are going to use good passwords, but after a while, when they have multiple accounts, they're going to use and reuse the same password for the other accounts as well, which in that case, when one of the accounts get compromised, all the other accounts which are reusing the same password are going to get compromised. Each account password should be unique, and this is something that not everybody follows, right? And not following this, as I mentioned, is going to turn everything into a vulnerable situation. Many security policies mandate that the passwords must expire. This also brings in more problem for the memory of the users, because even if they're using, let's say, 10, 20, 30 different passwords for the multiple websites or multiple services they're using, after the passwords get expired, they cannot reuse it. And now they have to find something else, which either is reusing the same password from some other site or some other services, or coming up with a password that may be weak. So users often take shortcuts and use weak passwords. They try to use common words, their own name, date of birth, the name of their pet, and stuff like that. which makes the passwords even more vulnerable because now they're easier to be guessed, they're easier to be broken and cracked because an attacker can start with trying those known words, those common words and all that, right? So when attempting to create a strong password, they generally follow very predictable patterns, right? Like appending the different letters, numbers, punctuations in a pattern and all that, or replacing with the already known patterns. Like as you have seen, a lot of people suggest that a password that uses this characters as a good password, right? But at the end of the day, you have to understand that these kind of patterns are already known by the attackers as well and are already being used in the cracking tools. So that's the problem. So using the patterns, despite the fact that there is a good group of people who call it, oh, that's a good idea. Let's have password as our main word, and then when it comes to different websites, just append the website. Like let's say just put google.com to the end of the password. So now I have a strong password because when I go to Yahoo, this changes into yahoo.com. Even though these sound to be good ideas, but they definitely are not because, of course, the attackers also understand that appending and replacing are the techniques that people use in order to uh, be able to easily memorize their passwords and utilize their passwords in different services and locations. But again, not a good idea. So the attacks on the passwords, basically when user creates a password, a one-way hash algorithm creates a message digest or a hash, as we have discussed it before through any of the hash algorithms. But we're going to revisit a couple of those in this discussion again. Attackers work to steal the file of the password digest. So basically they want to find the hash. As you know, getting the actual password from a hashed value is not really easy because you have to revert the hash algorithm. One thing that a cracker and a password cracker does is instead of trying to revert it, they're going to try different words within different algorithms to see which one is going to produce the same hash. Of course, this is happening through an automated procedure, right? What they do is they use a stolen hash to impersonate the user, or from the algorithm, they're going to find which word is going to be producing or which phrase is going to be producing the same password. And of course, they're going to use it. There are many different password crackers out there. You can use air cracking for getting the password. Kismet is out there. There are different applications out there that you can actually use for password cracking. Password cracking basically is as the act of trying different type of possibilities to see which one is going to generate the same result, and therefore that's the password, right? There are different means for creating the digests that a password cracker is going to create to guess the password. And some of those are like brute force, rule, dictionary, rainbow, and password collections, which we're going to be talking about those now. So the type of attacks that we're going to talk about in the upcoming slides are not necessarily the only type of the attacks on the passwords. However, these are the most commonly known attacks. And despite the fact that they're known and a lot of countermeasures and security controls are in place against those, still, even today, those are useful. And a lot of time, people who are learning security use these methods in order to conduct security experiments, like cracking into a wireless access point and stuff like that. So password spraying attack selects one or few common passwords and then enters the same password when trying to log into several user accounts. When you try this on a multitude of users, the bigger the number of users and the bigger the spray bucket that you have that you're spraying out of, the higher the level of success is going to be. But generally speaking, password spraying is not really a very good and a strong type of attack. So brute force attack is an automated attack which every possible combination of letters, numbers, and characters is used to create encrypted passwords and match it against the stolen hash file to see which one is going to generate the same hash file. There's also an online brute force attack, which in that the same account is continuously attacked. We call it pounding. By entering different passwords. Of course, each time that we are entering the different password and that is not correct, we're going to get an error. But if you be persistent enough, you're going to find the final password no matter within a minute or within 200 years, right? And note that most of these type of attacks, specifically brute force attacks, are relying heavily on how powerful and how strong the computation device which is conducting the attack is. But the power of cloud out there, some bad actors even use the cloud computing power and come up with humongous amount of processing power in order to successfully break into a password through brute force, because it's all about the repetition, how many times actually you repeat the attack, and how big of a dictionary or how big of a resource you have to read the possible combinations and compare those against the password or the hash algorithm to see what the result is going to be. The offline brute force attack actually uses a stolen hash file and as a slower, because you're going to have a stolen file and you're going through every single possibility offline. But it's a very thorough method because you have time to try every single possibility before you're being blocked by the system. If you have noticed, most of the services you log into, if you log in multiple times in an unsuccessful fashion, the system is going to block you out. But when you have the hash stolen and you have it offline and you're working on it, this is not going to be a problem for you, right? Then we do have the rule attack, which conducts a statistical analysis on the stolen passwords that is used to create a mask to break the large number of passwords. So basically what happens is, first, the attackers steal a small sample of passwords in plain text, right? So they successfully steal some plain text passwords, or they even can obtain those from the dark web in return of some Ethereums or Bitcoins. And then what they do is, for that specific entity or the community, what they do is they run a statistical analysis so that they can determine what is the usual length of the characters, the passwords, how many characters in each password is, how the sets of passwords are. Are there special characters and such? Basically, kind of determining the password policy that applies to that group of stolen passwords. And then based on that, based on the understanding of what is the common theme in these passwords, a series of masks are generated that will be most successful in cracking the highest percentage of the password. So they can know how many characters they need to generate, and then they try with the masks to kind of like switch the characters in those positions in order to find the passwords. Here you can see an example, like the analysis is telling us, hey, look, for the group of passwords that you actually have, the length of statistics says 62% of them are of 8 characters, 18% of them are 6 characters, and so forth, right? So you can easily see, to be successful in this environment, you want your password masks to be of possibly 6, 7, and 8 characters, right? Those three, as you can see, are composing the biggest chunk of this entire password, literally 97% of everything, right? And then look at the other analysis, like you have the character set statistics here that is telling us, hey, The lowercase are showing 47%, and the lower the actual characters are at 46%, and the numeric ones are at 5%. So basically, just note that through the analysis, you're going to figure out what is going to give you the highest possibility of success to go for. And then based on that, you're going to come up with the advanced mask statistics, which basically is a generation of what percentage of the passwords follow which format. Now that you have the format, it's easy to go on and put all what you learned from what type of characters are being used, what is the length, what is the format, and then go from there, conduct a rule attack, and find which one is going to be successful against those account IDs. We also have the dictionary attack. In a dictionary attack, the attacker creates digest of common dictionary words and compares those against the stolen digest file. This really is useful against the password of the users who use common words like come to the beach or come to the fun or anything like that, right? If they're using these terms or known words of dictionary in their password, the dictionary attack is going to be super useful because these are set of known words, right? So a pre-image attack is a dictionary attack that uses a set of dictionary words and compares those with the stolen digests. That's kind of like a selection of the words possible, and coming up with a smaller dictionary rather than a huge dictionary, right? We also have the birthday attack, which is the search for any two digests that are the same. So they are happening again and again and again, right? And that again helps the attacker to be able to guess the right password faster. And when we talk about guessing, we're not talking about literal guessing, right? We're talking about trying the possible combinations against the password and authentication system and return back a successful stat. We also have the rainbow tables, especially for the hash tables, right? So the rainbow tables create a large pre-generated data set of candidate digests. So basically what happens is you're going to take a dictionary, right? And from those words that you have, you're going to generate the hashes already. So now these hashes are already pre-made and ready. And when you steal, oh, by you, I mean the attacker for sure. None of you guys is going to do that, right? So when the bad actor steals the hashes instead of the plain text passwords, now they can compare those to the rainbow table data that actually is pre-generated. So they're already hashed. So the advantage of the rainbow table over the other methods is it can be used repeatedly because now you have the hashes and you can generate new hashes anytime, right? It's faster than dictionary attacks because the step of hashing already has happened and your rainbow table is actually a set of hashed values. And it needs less memory on attacking, and your machine doesn't need to be as powerful as what you need for the dictionary or brute force. So in 2009, an attacker used the SQL injection attack, and more than 32 million user passwords in clear text were stolen. These passwords gave attackers a large corpus of real world passwords, what people actually are using as their password, right? Not the random values that cyber specialists work with, right? So real world password were kind of like reveals 32 million is a huge number, right? So using a stolen password collections as a candidate passwords is actually the foundation of password cracking today. So all of the password cracking methods are using a type of candidate against the actual passwords to see if that matches. Almost all password cracking software tools accept these stolen word lists as input. Sometimes malware, the bad actors actually generate their own specific list of candidates, their own specific dictionary or the rainbow table that they use based on the type of community or entity that they're attacking, right? Especially if they already have some kind of reconnaissance and information about how the password policy of that entity is, it makes their life even easier. So passwords, as we said, were something you know. Now let's talk about something you have. First and foremost, smartphone and security keys, right? So smartphones usually are very useful in providing security to our accounts, right? So that happens through MFA or multi-factor authentication, which is a type of authentication where a user is using more than one type of authentication credentials. So you have two type of identification. For example, when you know the password and you actually have, let's say, a passphrase that is being texted to you, or you have this card, or you have this retina that is like unique for you, or fingerprint, any multiple type, right? When you have multiple type of authentication factors in place, you call it MFA. There is this 2FA term that is used when you have two different factors together. Most of you guys have experienced this when you log into your banks, like when you go to, let's say, bankofamerica.com, you put in your username, password, and then they sent you this OTP text, the one-time password text that you enter, just proving it's you because you have access to your cell phone number, right? Most common items used for authentication are specialized devices like smartphones, security keys, flash drives, Bluetooth keys, smart cards, and all of those. So a smart card holds information to be used as part of the authentication process. Those can be tapped, those can have a magnetic strip, those can have a barcode or anything like that that can be scanned. A good example of a card that has all of these together is a common access card, or CAC, that is issued by US Department of Defense for all the employees, right? So that has all of these all on one card. So they know the password and they use the card as the second identification mean. There are several disadvantages to a smart cards though. So each device that uses a smart card authentication must have a specialized hardware reader, and the device driver software should be installed. So if for any reason the device driver is corrupt, broken, or the hardware is not present in there, then you're going to have a big problem, because now the smart card is not going to help the person to be able to log in, and they're staying out. And if you remember from the triad of CIA, in this case, you totally are removing the availability, which means you don't have security anymore. Without availability, we don't have security. We have a full confidentiality. Basically, it's logged. So smart cards have a magnetic strips, which are subject to an authorized application called card cloning. Stealing the information is often done by a process called skimming, in which bad actors have these skimmers in their backpacks and their pockets, or even like a cell phone in their hand, and they just rub against you or rub against your wallet and read the information off of those, and then they can easily clone or duplicate the card and abuse the card after that. Specialized devices also provide the ability for using the one-time passwords. Windows tokens basically create a one-time password, or OTP, which is an authentication code that can be used only once for a limited period of time. Going back to our example of logging into Bank of America, every time you get that text message, it's telling you that, hey, this code is valid for a minute from now. And this is generally with all the OTPs, as the name says, that's a one-time password, but at the same time, it's time limited, right? Basically, you either have the TOTP, which is the time-based one-time password, which is synced with an authentication server where the code is generated from an algorithm, and both you and the device the server that is authenticating you have access. So whenever you receive that text message from the server, and you go and key it into your Bank of America webpage as your passcode, the Bank of America is going to check with the server which issued that to you. And if the code you provided matches the code that server has stored, then you're going to be granted access. Depending on what system you're using, these times can vary from time to time, but 1 minute is kind of like a standard time now for most of these TOTP providers. We also have HMAC-based one-time password, or HOTP, which is an event-driven system and changes when a specific event occurs. Basically, think about whenever you open a certain application, that can be an event to send you that one-time password. Whenever you want to download a file, that can be an event to send you that one-time password, right? So another good example in Bank of America one is when you log in and you are in your bank dashboard and you're doing banking, you're not being asked for a password. However, as soon as you start requesting a transfer from your account to another account, what happens is HOTP gets triggered, right? And you're going to be asked to enter that passphrase again, that code again. And that's a good example of HOTP, which is triggered by the event of trying to transfer funds to a different account. So once a user enters their username and password in the website, their smartphone is then used for the second authentication factor using either a phone call, SMS, text message, or even the authentication apps. You have the Microsoft Authenticator, you have the Secure ID app. There are multiple apps that actually can act like the code you get from your SMS system, from the text message system. Those authenticator apps can provide the code to you, or some of them can just approve the connection. So in the server side, whenever you try to log into the server, your request is being sent to an authentication server, which then is going to be sent it to your authenticator app on the cell phone. And then if you click on approve, you tell authentication server that the service is now allowed to allow you in. And basically you approve the logon. So if somebody else is trying to do that, it's impossible to happen because they will never receive the code, or they will never receive the approval request. So a good example is how the Adobe is using the authenticator for authentication into their Creative Cloud application suite, right? So using a smartphone for authentication is not considered really that secure, because an OTP received through an SMS text message can be phished. A malware infection on the phone can target the authentication app, or any kind of security problem, any kind of vulnerability on your phone being exploited may end up with your OTPs being stolen, right? So that's not, we cannot say it is not secure, but it's not the best secure situation. So we trust the phones because in many situations, for the sake of the availability of CIA, it's almost impossible to provide key to everyone. Think about our example. Bank of America cannot give every single one of us a key and control all of those keys, right? So they trust their cell phones to some level. A security key itself is a dongle that is inserted into the USB port or Lightning port or held near the endpoint. A feature of security key is attestation, right? The attestation is a key pair that is literally burned into the security key, meaning you have a chip that is not rewritable on your security key that has this code burned into it, this key burned into it. And this happens during the manufacturing and is specific to that device model. Attestation keys have associated attestation certificates, and those certificates chain to a root certificate that the service trusts, and then they're going to be helping your authentication turning into a successful stat. Some security key systems requires that users must initially enroll two security keys in the event that one is lost or destroyed. So basically, they're asking you to have a backup key. With the backup key also comes the question of physical security. Where are you storing it? How are you storing it? Can the backup key be compromised and all of that? But again, remember, we are in the middle of the triad of CIA. We're trying to get to the point that has enough C, enough I, and enough A, and not compromising or let's say dropping any corner. So now that we talked about something you know and something you have, let's talk about something you are, which basically means biometrics, right? Which is physiological biometrics of a person. So physiological biometrics uses a person's unique physical characteristics for authentication. Several unique characteristics of a person's body can be used to authenticate. We have retinal scanners, which use human retina as a biometric identifier, which basically maps the unique pattern of a retina by directing a beam of low energy infrared, which is IR, right, into a person's eye, and then reads back and maps the retina surface characteristics. There are two basic types of fingerprint scanners that come to play on side with retina scanners. We do have the static fingerprint scanners, which you just rest your finger on those and they take a picture. And we do have the dynamic fingerprint scanners, which you need to slide your finger over those. So this picture is an example of the dynamic one where you need to actually slide your finger over it, and it only has one line that scans the entire finger of yours as your fingers move over it. There are some advantages from these ones on the static ones, because static ones can be fooled way easier than dynamic ones. Other human characteristics that can be used for authentication are somebody's VIN that can be identified through a VIN scanning tablet. A person's gait or manner of walking actually can be analyzed through machine learning. And we do have the standard input devices that they can look and hear somebody's characteristics, like voice recognition, which uses a standard computer microphone to identify users based on the unique characteristics of the person's voice. We also have the iris scanner, which uses a standard webcam to identify the unique characteristics of the iris, as we discussed. We also have facial recognition, like what you get in your new smartphones, right? Like I know Apple is doing very well with their Face ID. That's what you have here. The facial recognition uses landmarks called the nodal points in human faces for authentication, and they need to have a LiDAR so they can actually have a 3D scan of your face so they can make sure your face is actually your face. So with biometrics come many disadvantages, right? So first of all, cost of specialized hardware scanning devices is really high, and you need to have it everywhere on every machine that you want to protect with this type of scanning. Of course, there's some devices that already carry those inside, like as we said, the iPhones or Android phones, they carry those inside. Some tablets and laptops happen, and that's where you have the Windows Hello on this new Microsoft Surface tablets, right? Which enable you to be able to scan your face. But at the end of the day, in an enterprise, think about that you need to equip each machine with the specialized hardware, because most of enterprises are not resorting to these more expensive devices as the devices they provide to their employees. Also, readers have some amount of error, and this some amount has been proven to be even larger than what you can imagine. Like twins can easily unlock each other's devices, or brothers, sisters, siblings, basically, when they are more similar and they don't have specific landmarks on their faces on all that, then they can actually imitate each other, right? In that sense, we do have two parameters that we calculate in order to see how well a system is. We do FAR and FRR, which the first one is false acceptance rate, which is the frequency at which imposters are accepted as genuine, which should be as low as possible to have a good device, right? And we do have the false rejection rate, or FRR, which is the frequency that the legitimate users are rejected. So as you can see, either or is considered a bad security control, because even in the false rejection rate, you again have removed the availability. So think about it. If someone tries their phone multiple times and they get rejected, after a while, they're going to remove that security feature. They're going to resort back to the passwords or even pin the identification pins, which 4 or 8 characters is the max that you get on most of the phones, right? And this means you're just pushing them back to less secure way, and your MFA basically is not only not bringing in any advantages, but also brings in the disadvantage of pushing people back, pushing users back into less secure means. So as we said, biometric systems can be tricked. Twins, again, are a good example of that. And a concern with biometrics is the efficacy rate, right? Which efficacy may be defined as the benefit achieved. Critics question the sacrifice of user privacy here as well. Of course, that's your biometrics, that's your privacy. And so there are some systems that store them off-prem, meaning that it's not stored on your cell phone, it's actually stored on a server or somewhere. And that's a question of, hey, what happens to my privacy? We also have more advanced methods like cognitive biometrics, which relates to a perception, thought process, and understanding of a user, right? What you actually can do. Can you solve this mathematical problem? So maybe I can use it as a password because this is a mathematical problem that not everybody else can resolve, right? This is an extreme example, but that's just there for you to understand what do we mean about when we say cognitive biometrics. This is considered easier for the user to remember because it's based on users' life experiences, right? Like I can show you pictures of the places that I know you have gone to. And if you can choose everywhere that you have gone to throughout your life, it's kind of difficult to imitate that and duplicate that, right? So picture password was initially introduced by Microsoft for Windows 10 touch-enabled devices like the tablets. And users were to select a picture to use for which there should be at least 10 points of interest that could serve as landmarks or places to touch, right? The other thing is some websites use the picture password as the second means of authentication. So when you set up your account, you choose a picture to be your second password authentication based on your interest or based on anything that you can always remember. So every time you go, they show you 10, 20 pictures and you just choose one. Of course, this is not going to make it super secure, but it's just one step more in controlling the confidentiality and the authentication process. So now let's talk about something you do, which is the behavioral biometrics. This basically authenticates by normal actions that a user performs. A type of a behavioral biometrics is keystroke dynamics. Think about how you type, and if you have seen other people typing, you can see different rhythms, right? Different ways, and that all goes back to your dwell time, which is the time that your finger actually dwells on a key, and the flight time, which is actually the time that you go from a key to another key, right? Looking at this, just looking at the dynamics of the keystrokes, you basically can guess if this person is the person that he claims to be because this pattern goes back to him. However, this is not really used that much right now, but it has a lot of potential because it requires no specialized hardware because the keyboard is already there. You don't need to add any hardware. You just need an algorithm, a software code behind the scene to learn the pattern of the typing that people have, and then just consider it the second way of authentication, especially in 2FA or MFA. So if you type your password and the way you type your password is not matching your normal behavior, then that's not you. So you're going to be asked to type it again, right? So let's do a quick knowledge activity here. What process can be done on a smart cards that steals the information contained on them? Yes, the survey says skimming. Now that we talked about the authentication needs, let's talk about the solutions that are available to us in order to provide the better authentication. Talk about the protocols and all that, right? There are several solutions for securing authentication, whether security surrounding the passwords themselves, policies, rules, and all of that, and then security authentication technologies like the protocols and the devices that we use. First and foremost, to protect a password, there are many ways. One of them is fooling the attacker into believing the password they see is the actual password. That method is called salting, which basically consists of a random string that is used in a hash algorithm. User enters their password, right? Let's say if I just type password here, let's say this is my password. And what happens is the system, before hashing, adds a character before the last two digits. Now this is going to be hashed. And that is basically, this one can be any character. It's a random character, right? However, if you enter this whole thing as a password, that's not going to be accepted because the password is actually password. So remember, you enter this, then the system authenticates it through adding that salt to it. Make sense? This way, if someone steals your password, they think your password is password 2D, right? And they enter it. What happens is system adds another 3 or something after that, and it turns to this, and it's not going to hash into what you actually need to be hashed into, to be accepted. So passwords can be protected by adding a random string to the user's clear text password before it's hashed and after user has entered their password. Salts make dictionary attacks and brute force attacks much slower, not rendering useless, remember, much slower, and limit the impact of rainbow attacks, because now even if you find the hash, you have find the hash of a password that is salted, not the actual password. And you never know which character is the salt. Of course, in my example, it was obvious that that number should be the salt. But if that was just a character and this is a, let's say, meaningless word, it's very difficult to find it. However, bad actors and attackers actually know that salting can happen, and they do analytics over this to see if a salt is in place. And as soon as they find the salt in place, through a rule method, they're going to go ahead and try all the possibilities for masking the salt. That's why we say it makes it slower, because they have to go through more steps in order to break into. And that means if they don't have enough processing power, if they don't have enough memory on their systems, it's going to make it impossible for them, right? Another method is key stretching, which is a specialized password hash algorithm that intentionally is designed to be slower, meaning the attacker also needs to spend a lot more time on breaking into a password, and possibly because of lack of processing power or the time, it's going to be useless, right? However, remember, this also makes the authentication process a little bit slower, even when the user logs in. I mean, that's not a huge deal for the user, because user only experiences one round of algorithm run, but the bad actor experiences millions of times of algorithm run. So that extra added time through key stretching is going to render their job very difficult. There are two known algorithms, two commonly used algorithms for those. One is BRIPT and the other one is PBKDF2, which is out, the algorithm itself is out of the scope here, but it's actually a food for thought to go and look into the algorithms and learn more about this means of password security. The most critical factor in a strong password is length. Again, the longer the password, the more secure the password is, the more difficult breaking and cracking that password is going to be. So, due to the limitations of our memory, security experts universally recommend using technology to store and manage the password, because if that is a long password, we cannot memorize it. So they say, hey, use technology, right? Technology used for securing passwords can be password vaults, password keys, or hardware modules that they actually keep your passwords. The password vault is a secure repository where users can store passwords. Also, you call them password managers. You have these actually on most of the platforms you're actually using these days. On Chrome, on different other browsers, the browser saves your password. Also, the browser suggests a very difficult to guess password. Those long passwords with a lot of characters involved. That's what a browser suggests to you because the browser can keep those, right? Also, you have the Apple keychain, you have the Android, Samsung Pass, and all of those, which are basically vaults that they keep your password safe. Therefore, you can just go with any type of long password because you don't need to memorize. You just need to have access to the device. When you authenticate to the device, you're going to have the possibility of using all of those whenever you need them, right? Basic types of password vaults. We have the password generators, online vaults, or password management applications, which we just discussed. Password keys are a secure hardware-based solution to store the password. These are just hardwares, right? Like, look at this. This is a good example of a password key. This one actually holds 6 different passwords, and you can just connect it. And whenever you need to drop a password into any application or authentication page, you can just push or press the key here, and the password is going to be posted, right? We also have an HSM, or a hardware security module, which is a removable external cryptographic device that includes an onboard random number generator to generate your passwords and a key storage facility to store your passwords. An HSM can also perform encryption and can also back up sensitive material in an encrypted form. Some newer devices, like newer laptops, they do have HSM on board, right? And they help you with encrypted backups and password management. The other thing that we need to talk about when it comes to password security is secure authentication technologies, right? And the first and foremost is the single sign-on, or SSO. So identity management is using a single authentication credential shared across multiple networks through single sign-on. This is what you guys do when you use Facebook in order to log on to different websites, or use your Chrome in order to log on to different websites. That's literally the single sign-on. It's also called federation, or federated identity management, or even FIM. When networks are owned by different organizations, you can use federation in order to have only one credential and then go to different networks. Think about that you have on-prem services, right? Which are provided by the physical devices that you have on-prem. And then your company is using multiple SaaS and cloud services as well. So each time that you want to log on to those, if you're on the company computer and you already are logged on, you just need to navigate to that website. And the authentication is going to be sent to them from the Active Directory of your company, and you're going to get authenticated automatically. That's when a federation between that SaaS service and your on-prem system has happened, and that's what the single sign-on is, right? It uses one authentication credential, authenticates you once, and then you can access multiple accounts, application tools, and all that, and within the realm of the same network or multiple networks that are interconnected. To do that, of course, you need to have a SSO manager like the Active Directory or anything in that realm. We're going to talk about Active Directory a little bit later. So also, you can use authentication services, right? There are different services that can be used to provide authentication. The oldest of all is Radius, or Remote Authentication Dial-in User Service, which was developed a long time ago. And back when the computer world was young, it was industry standard, right? It was originally designed for remote dial-in access, like through the phone, basically, dial-in access to a corporate network. You remember those modems that were screaming to get connected? That's where the Radius was being implemented, right? Radius client is typically a device, such a wireless access point, that is responsible for sending user credentials and connection parameters to the Radius server so that the server authenticates them. User profiles are stored in a central database that all remote servers can share. They can all have access, so all the Radius clients can just read that from the Radius server and use it to authenticate the user which is dialing in. Remember that the client does not necessarily need to have all of that data locally stored, and that brings a higher level of security because you're going to have just a single administered network point, right? And it's going to be easier to track usage for billing or auditing or anything in that realm. So over here, you can see the example of how Radius works, right? So basically, a user sends the ID and password to the access point, and access point sends the authentication request to the Radius server, which then is going to forward that to the database and information in the database, right? And then the authentication acknowledgement comes back to the user. Immediately there, we go back and we write the records in the accounting database. And this accounting is different from like financial accounting. This is network accounting. This basically is auditing, right? So as soon as the token is delivered to the user, the accounting database knows this user is logged in at this time, right? And then later down the road, you're going to learn that this accounting databases also follow the user with what they do in there and what are their actions in the network. The concept of AAA, or authentication, authorization, and accounting, which we're going to discuss later, actually is observing the same way of communication. And finally, after, and note that only after the record is in the accounting database, approval to the user is going to be delivered, and now user has access to the network as they need, right? So Radius was not the best ever. Of course, MIT, always in action, went through, and students and professors in MIT developed an authentication system called Kerberos, which uses encryption and authentication for security. It works like using a driver, like a passport, right? You need a passport. What Kerberos does is give you a passport to go through the network. Those are called Kerberos tickets. So when you log in, Kerberos gives you a ticket, which is really difficult to copy, which contains information linking to you and your user account, which also has the restrictions applied to you. So the ticket knows where you cannot go, what you cannot touch, and also expires at some time after you log in. This means you log in with the Kerberos, receive the ticket, which is like your passport, go travel wherever that passport allows you, do whatever that passport allows you, and then come back. So whatever you want to do in the network, you have to show that passport or ticket. Kerberos is typically used when a user attempts to access a network service And that service requires another level of authentication, which within most of advanced networks, almost always you need to authenticate into any service within the user, because that is in place to reduce the possibility of lateral movement. When an attacker can take a foothold in your network, then when they move around, if they don't have the Kerberos ticket, they cannot use other services or abuse other services, because every time they want to touch a service, Kerberos ticket is required. So same to Radius, the Unix and Linux systems use a protocol called Terminal Access Control System, or TACACS and TACACS Plus, which is the newer version to TACACS, right? TACACS is an authentication service that is commonly used on Unix devices, and forwards your authentication information to a centralized user, exactly like what Radius does, but on the Unix platform. The current version of it, the updated version of it, as I said, is called TACACS Plus. One of the biggest players in this game is directory service, right? Microsoft version of it calls it Active Directory Service. A directory service is a centralized database which contains information about everything: users, resources, network devices, even sometimes files and folders, everything that can be onboarded to the directory service. It makes it super easy to manage permissions and access to different resources. Like it applies something called an ACL, access control list, to each resource. And every time a user authenticates and gets into the network, what it does is it provides a ticket or a passport to them. So now that they can use it like what we had in Kerberos, not exactly like that, but the discussion over directory service is gonna come very soon in this series of videos. We do have the advanced, or let's say the business-to-business protocol here, SAML, or Security Assertion Markup Language, which basically is an XML. XML stands for Extensible Markup Language. It's basically a data file with the tags that user decides what to put in, right? SAML is an XML standard that allows secure web domains to exchange user authentication and authorization of the data. It allows users' login credentials to be stored with a single identity provider instead of being stored on each web service provider's server, very similar to what you have in SSO. SAML is used extensively for online e-commerce business-to-business and business-to-customer transactions. So a lot of companies nowadays, when they open up an API to another company, they use SAML and Active Directory together in order to manage the access. And these are going to be discussed more in details very soon, right? So let's just quickly look at the SAML transaction. So we do have user here. We have the service provider, SAML service provider, and then we do have the identity provider over here. In a SAML transaction, user first attempts to reach the service provider, right? Hey, I need your service. Provide me with the service. Service provider generates the SAML request, which then is going to be redirected back to the user, which then user sends it to the identity provider, which then decodes that request and authenticates the user and sends back a SAML response to the user, which is now approved by the identity provider. And then user forwards the SAML request to the service provider, and service provider basically then accepts it and allows user to log in. So as you can see, user goes to the provider, provider tells user what are the requirements, which is the SAML request, and user goes to identity provider, gets authenticated, and comes back to the service provider just to log in and start using the service. Authentication framework protocol. So before we end this, let's just touch on the framework protocols that are out there and being used for authentication. A framework for transporting authentication protocols is known as the extensible authentication protocol. So basically, as soon as it turns into a network, a framework, we call it an extensible protocol, or EAP, extensible authentication protocol. EAP was created as a more secure alternative to CHAP, or Challenge Handshake Authentication Protocol, which is the older one that we discussed earlier in this video. Microsoft version of CHAP, or MS CHAP, and Password Authentication Protocol PAP are those that you have substituted, right, by EAP. And these days, EAP is the framework for transporting authentication protocols instead of authentication protocol itself. Again, this is not the authentication protocol. You may be using Kerberos, but you're using it on top of EAP. So it's just for transporting the authentication protocols, not the authentication protocol itself. EAP defines the format of the message and uses 4 types of packets. There is a request packet, response, success, and failure. If we come back here, remember a request packet, a response with the answer of, hey, is that failed or is that successful? That's what the framework defines, and that's the EAP that we have over here. So let's do another knowledge check activity here. Which standard allows secure web domains to exchange user authentication and authorization data? Okay, the survey says the answer is B, SAML. Let's see what did we cover in this video. Authentication credentials can be classified into 5 categories: what you know, what you have, what you are, what you do, and where you are. Passwords provide a weak degree of protection because they rely on human memory. Most password attacks today use offline attacks where attackers steal encrypted password file. A dictionary attack begins with the attacker creating digestive common dictionary words, which are compared with those in a stolen password file. Another type of authentication credential is based on approved user having a specific item in her possession. A hardware token is a small device that generates a code from an algorithm once every 30 to 60 seconds. And we said these days mostly they're at 1 minute. Biometric basis authentication on characteristics of an individual. Standard and cognitive biometrics are the examples we went through. We also talked about behavioral biometrics authentication, which actually looks at the normal actions of the user, like how they type. One way for an enterprise to protect a stored digest is to add a salt, which consists of a random string that is used in hash algorithms. We also scratched the surface and touched on single sign-on, which allows a single username and password to gain access to all accounts. Different services can be used to provide authentication, and we talked about some of them, and finally we discussed the EAP being the framework. With that being said, we're going to go ahead and stop this video.